Here you go. Textbook is about heading at your place. All right. So, sorry. Thank you. So double angle formula. So right now we already talk about. We get to the stage that we already talk about sum and difference. So imagine that if I have a sum and difference of sine of two data, again that's equal to sine of data plus data. Use sum and difference. So that will give you sine, cosine, cosine, sine, data, 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 plus together. So since they are the same, so it'll be 2 sine data, cosine data. So that is the first double angle identity that you have on your list, right? Yes.
Why is it two cosine? Like two tan, not two cosine as
well? Imagine that this is a good question. Imagine that this is x, this is y, right? And this is y, this is x, right? So I can change this to xy, right? So that's only 2xy, not 4. Is that okay for the double angle identity? That's pretty easy. Yes. Um, for me, like in case I forget, I know how to prove it. So at worst to worst, that you can always prove it. But for me, like it's much better to memorize it. But it's not hard to memorize. But if you don't memorize it, you can prove it. That's a nice thing about math is like I don't remember a lot of equation. A lot of time I'm just like write my own proof, kind of figure out. Like for example, like how do I know 1 plus tangent square x equal to secant square of x? I divide it by sine square, cosine square, divided by cosine on all of them. And now find out tangent square plus 1 equal to secant square. So I can like derive inside my head is much very, very important. Later on, we're going to learn something called verified identity. And that one's going to be probably the hardest section. Now, I think it's important, but College Board doesn't think it's that important. But I'm gonna teach you. I'm gonna have a test on it. Because you use it a lot. So that's what I think College Board is not that good. So this one you can. I would say just memorize if you can, right? So cosine through data is gonna be equal to cosine of data plus data, and that's equal to cosine, cosine, sine, sine. If you do it so many times, you probably see that this is no longer need a memory anymore. So that becomes cosine squared theta minus sine squared theta. It looked like kind of like Pythagorean, but it's reverse order and it's minus. So this is cosine 2 theta. So this becomes this one that we can choose to memorize it as well. It's not a problem. Now remember, this is only the first of double angle for cosine. There are two other one, and it's involved with cosine 2 theta is equal to this one. I'm going to change to 1 minus sine squared theta because why? Sine squared theta plus cosine squared theta is equal to 1. So 1 minus sine squared equal to cosine squared. Is that okay? Minus sine squared theta. So that's equal to 1 minus 2 sine squared theta. And that becomes the second identity. I didn't memorize this. I understand it. I didn't memorize it. Now, I am going to copy this one again. And I'm going to paste right here. I say, okay, well, instead of switch this cosine to sine, I'm going to switch the other way, right? I'm switching this one becomes 1 minus cosine squared theta. And I'm going to keep this one the same. And this one's going to be here. But if we distribute, that becomes adding. So it'll be 2 cosine squared theta minus 1. And that's cosine 2 theta. So there are 1, 2, 3 version of it. So that is the first version. There's the second version. There's the third version of cosine double angle identity. Now I'm going to talk about power reducing. So this lead to power reducing. And power reducing basically just says, hey, is there any way I can represent second degree function as a first degree function? Usually that's very impossible a lot of times, but for trig, you can. So I am gonna copy this because your angle is get sine squared by itself. So I'm just gonna copy, I'm gonna paste here. I say, hey, what about if I just get this, right? If I just get this, sorry. If I just get this by sine square, or if I get this by cosine square. So copy and paste. I didn't do anything crazy. This is power reducing. This is how you come up with the power reducing. So I didn't do anything crazy. So power reducing, you want your angle to be sine square is equal to something, right? So can I just say, hey, I want to evaluate for this particular thing and this particular thing here. I'm going to start with the one on the right because it's a lot easier. You move the one to the other side. So that becomes 1 minus cosine 2 theta is equal to 2 cosine squared theta. And I'll just divide it by 2. Does that make sense? So the cosine squared theta is equal to 1 minus cosine 2 theta over 2. Yep, plus. It's not actual memory. It's just take one function and solve for sine square or cosine square in this case. I'm going to do the same thing on this one, but this one requires one extra step because if I move to the other side, it's because 2 sine squared theta plus cosine 2 theta is equal to 1, and then move this to the other side, so it'll be 2 sine squared theta is equal to 1 minus cosine 2 theta, or divided by 2 on both sides. So it's basically just solving the equation. So a lot of people says, oh my god, Mr. Ye, I need to memorize 22 formulas. All 22 formulas are related. They are one correlate to the other. Like sum and difference is the only one that you had to memorize the acronym. Everything else is derived from previous identities. So that's why there's so many identity, and that's why a lot of people fail pre-calc. It's because they do not see the connection between all the identities. I'll try to teach you all the connection as much as I can. Now this formula sheet doesn't have something I wish I had, okay? And because I want to choose to add this one, just because it is on SAT. Okay, so on SAT, you will have a question involved with co-function identity, which is we already talked before. But co-function identity usually talk during like graphing. But since I skipped graphing this year because I think graphing is going to be separate by its own because a big portion is going to be graphing on the SAT. So I'm going to spend like one dedicated time just focus on graphing a lot more. Okay, so any question about this part? Sure. Yeah. Co-function identity, make sure you know it. Very, very useful. This too, I suppose, talk during graphing, so we'll do that. Let's see where they're at though. can't find it. But anyway, cofunction identity is equal to sine of theta equal to cosine of pi over 2 minus theta, or sine of theta is equal to cosine of 90-degree minus theta. And we talked about this before, because if you type in, let's say, sine of 10 degrees, it's also equate to cosine of 80 degrees. And we're going to show you something that is very interesting. Is this okay?
Yeah, is that like minus?
Yeah. And there's a reason why, because if we did deal with teach you the graph already, there's a shift of pi over 2. But that's that. So is this okay? Is this okay? Same thing that it will work with any other functions, and they arrange the same order. Let me type in. I just don't want to give you wrong. So, here apply for cosine as well. Cosine cosine of theta is equal to sine of pi over 2 minus theta, or cosine theta is equal to sine times 90-degree minus theta. So these are the same. Tangent and cotangent work as well. So tangent and cotangent is gonna be is equal to cotangent of pi over 2 minus theta, or tangent of theta is equal to cotangent of 90 minus theta. Okay, so this is a commonly used. Now I want to show you something that's really interesting, because when I was school, which is 19, sounds like centuries ago, 1995, I was learning this in junior in high school. I want to show you something that's very interesting. Roughly. I'm old. Old man. Old man. I'm trying to look for this table that is very hard to find now. This is a very interesting one. But I cannot find it. Exact value trig table. It's becoming so obsolete that nobody ever see it anymore. But it looks like right here. Okay.
Oh, bro, Mr. Robinson gave us.
Okay. So so let me take a screenshot of this. And let me zoom in as much as I can. Okay. So this is a table of the thing. Back then, we don't have graphing calculator. So we cannot find certain things, right? And you're like, wait, how do I use this table? It's so weird. How do people use this table? And there's a reason why this way, the arrangement of this way is actually very, very interesting. If you look at it, let's say, pay attention how the table goes, right? 0 to 45 degrees on the first column, and all the way to the end has 45 to 90 degrees, right? And there's on the top there's sine and cosine. On the bottom there's a cosine. There's cosine and sine, tangent and cotangent, cotangent, tangent, cosecant and cosecant, cosecant and secant. Okay, so what if today I ask you, says, hey, can you find me sine of 24 degrees? Can you tell me, find me a value of sine of 24 degrees? Huh? 0.4067. Good. Now, what if today I ask you to find sine of 70 degrees? Can you tell me what sine of 70 degrees is? Sine of 70 degrees?
I can't see that. Yeah, I can't see. Yeah,
Sine of 70 degrees.
What?
0.342 is wrong.
why is that?
How is that wrong? If it's on the right, you correlate it with the bottom, and then the left, you correlate it with the top.
So, yeah, Diego's on the right track. Denisia's on the right track. See, this is sine and cosine. This table is a very strategic engineer. It's like here. Let me send you this chart so that way you can see. Let me airdrop to you. So let me airdrop it to you, and somebody post on the group chat if you can. So this is a very cool table because you utilize the co-function identity really well. There was a way why they choose to stop at 45 degrees. They don't do 46 degree. If you realize that 46 degree they did use, but it's going this way. Do you see that? 46 degree. And sine of 46 degree is going to be 0.7193. And that is how the orientation is going to work. So when I was school, I used this. So we have 4 function calculator. We don't say we don't have no calculator. So if we say we want to find angle elevation of 73 degrees, so we're going to go to 73, and we're going to use sine. Sine is going to be right here. So that is equal to 0.9563. Do you see that? And this becomes very interesting because if the more you recognize this chart, it kind of makes sense because they are 90 minus theta. They are 90 minus theta. So whatever is 25 degrees is, right, it's going to be the other ones of cosine of 65 degrees. They are exactly identical. Do you see what I'm saying? Because you look on the bottom, cosine, and that's the way it works. So it actually saves a lot of paper, and just one table you can use it all. Now here's my questions. All right, let's see who can figure out this. What if today I ask you sine of 100 degree? Sine of 100 degree. Can you tell me what the sine of 100 degree is? Sine of 100 degree.
0.98.
0.173.
Yeah, that's 0.984.
Is it
1736.
Or what if you add 90 and all the right there now?
0.984.
Sine of 100 degree.
1.1736.
Wait, what did you say?
You use calculator?
Would be that right now.
No, I.
Had seen her. Okay, Sydney was right. But I don't know if you look at a table or you type in the calculator.
Wait, what was the
0.9848.
That's what I said.
Do you know why now?
He goes, no, I want this, and that.
Because sine of 100 degrees is on second quadrant, right? And you want to have the same height on the first quadrant. So the only way is look at the sine of 80 degrees. And sine of 80 degree is right here. If you look at here, 80 degrees sine, that's 9848. And that's how you react to those informations. So we have this table, but we only have all the way to 90. But rest of them I have to figure out on our own. Does that make sense?
So you just add 90 and 10 and then go to the one.
Yeah, I go reflect to the first quadrant. Reflect to the first quadrant. So it's kind of thinking. So here, let me ask you a question. You guys ready? What is sine of?
How is sine of 100?
Okay.
Yeah.
No, that's fine. I always appreciate like Sydney. She has, if she had questions, she asks right away. And I think that's something like a lot of you guys don't have, that the courage to asking, which is fun. I think I'd rather explain to you. Like imagine that 100 degree is right here. That's why I say drawing the angle is kind of important. Let's say this is 100 degrees. This is 90, right? So, and the reference angle here is what? Here's 80 degrees. Does that make sense? So that means I need to go to here, the 80 degrees here. Because that gonna give me the same height of this. This same height of this. So therefore I can say, well, I just look at the sine of 80 degrees because if I reflect to the first quadrant, I can see the value. Does that make sense? Okay. So what if I take that table and I say, hey, let's look for sine of, I don't know, 200 degrees. Be careful. Be careful. Sine of 200 degrees. What do you think it is? If you know it, raise your hand. Hold on, let me give you sine of 200 degrees. So that's why you gotta think of a reference angle all the time.
That's what you mean by the red
.342.
Did you look on Google like Sydney did?
Makes sense though.
Emily, what?
100, 200 is here.
Yeah.
No, that's the wrong answer.
Hey, I get it. It's .342.
It's wrong answer.
It's 20 away from Negative.
Negative is correct.
Oh.
How? How is not even on the
Exactly, it's not on the chart. Why? Because 200 degree, it's at third quadrant. Your y is going to give you a negative value because of below x-axis. So even the value that's given to you at, you look at a sine of 20 degree, which is 0.3420, is correct, but that's only if sine of 20 degrees. But you are looking sine of 200 degrees, which is 20 degrees below 180.
So if it was like in the fourth quadrant, like if you're looking for sine of like 300, would it be positive?
Will be negative.
Oh, yeah.
Does that make sense?
Yeah.
It's kind of interesting, right? Why do they give you a degree that only all the way to 45? And they go in the other way all the way to 90, but they don't give you all other information. You ready for pop quiz?
We have 2 minutes actually.
All right, what is the cosine of?
With the chart?
Yeah, with the chart.
Okay. What?
cosine of, I don't know,
182.
cosine of 265 degrees. Cosine of 265 degrees.
What did you say?
Cosine of 265.
It's like a lot.
I'm teaching you guys old math that is already lost. You can't even find this image anymore.
Oh my gosh. 0.9962. Negative.
Cosine of 265.
That'd be possible.
Oh, wait, yeah.
But would it be the one that was? No, no. Yeah.
Wait, is it negative?
It can't be.
It starts
No, it's not. I
Yeah,
don't
it's close.
know. It's good.
It's fun.
Isn't it the second?
265. Wait, no,
Yeah.
Yeah.
Think about that one.
What'd you guys get?
Yeah.
That's what I got. I went first.
Go ask Google. Ask Google.
It's right.
You don't know?
I know the answer.
Is it not?
What?
It's right.
With what Emily says.
What's the difference?
What? Okay, cosine of 265. 265 is really close to y-axis on the bottom. Exactly. So you're right with saying
Look at the degrees. You look for 85.
so you should look at
Yeah, but
cosine 85 degrees, but you gotta put it negative.
the first.
Now cosine of 85 is 5 degrees. So you look at a 5 degree.
What, bro? But I don't get it.
Yo, we're talking. Yeah.
Back in the day when there's no AI.
I don't even use it.
I use AI. I think it's fun. Every time I'm like looking at checking the AI, if AI can solve the problem. They used to be very low scale. They used to cannot even solve algebra 2 kit problem. But now they doing some math competition problem and that's pretty good.
His two told me is like that's his math teacher. It's not his ChatGPT.
Hey, Mr. Yeah, do you know what the math baking test for UCF is?
Like, yeah. What is it or when is it?
What is it?
So when you go graduate high school, if you got no, so used to they don't have no AP pre-calc. So they will be pre-calc. So even you finish pre-calc, because a student like let's just say you have Mr. Robinson or pre-calc honor, and
You didn't learn.
you didn't learn anything. So when you go to, but that happened very everywhere. So you didn't learn anything. So you go to college. They say, well, we need to test your math skill, and they end up they test you, and you find out that you have below algebra 1 skill. So they will place you back all the way back to algebra 2 or college algebra. So that's why it's so essential for people pass AP exam because that can act as a placement test. I don't know for pre-calc though, but I know AP calculus for sure you can just place out a college algebra, place it out of pre-calculus, and you if you got a 3, you can start with calc 1
Yeah.
in
You pass. You just need to pass Calc AB. And you start like. with
Yeah,
the
but he
credit.
doesn't have a choice. He's a senior. So he had to pass the pre-cal with a 5, and you probably more likely they will ask you to take a placement exam. But if you're from my class, taking placement exam is not that difficult.
Like how like hard would it be compared to like one of your tests?
I think they are multiple choice, but it is. I think there was some question are pretty hard. I have a student who got a 4 on AP Calculus and ended up still taking the placement exam, and they still struggle in algebra. Um, but he passed. So
Should they study for it or?
I mean, if you do all the stuff that you're supposed to be doing here, then good. But it's somewhere in that pile, and I don't want to go look at it. Yeah. Yeah, but it's interesting, right? How old math is like.
Yeah, so much like.
Yeah, because we don't have calculator back then, so how do they come up with something? And they don't want to have like 20 page of data of sine of 1 degree all the way to 360 degrees.
Yeah.
And so they
like, yeah.
they find a way to concise it down.
Everything to one.
Yeah,
not
to
even
one
that,
page.
too, it's like one side of the page.
Yeah. And this is the old days that how they find any angle.
They had like just carry one of those around. That's crazy.
Yeah. Well, they used to have a slide rule. Slide rule can find a way to calibrate it. So you basically ruler. You can. It's like acting like an old engineer back in 1960 used the slide rule to approximate a value. They can approximate value square root 2, square root 7, square root 8. They can give you a pretty close value. Just use is it look like a ruler, but just slide it around and you can look for the value that you're supposed to.
How does it even like estimate?
They calibrate it. They calibrate it in a way that you can see it. So if you look up slide rule, how to use slide rule, and they will actually tell you how to use it.
I'm guessing it's like the abacus.
This is a slide rule.
Oh, I thought it was like way more complex. I'm running Sepher, bro. We're practicing. Yeah. Can I practice today or what?
The slide rule is one of the coolest, perhaps most important technological instruments that people today have only the dimmest idea what it is.
1916. Yeah.
You know, for example, we have a curve. You can put it in the air and then you can like measure like how big the head of the curve is. And I don't know what the flight apart is for.
Do we all understand exponents?
Absolutely.
Right?
MIT student doesn't know what a slide rule is.
But the question was
I didn't grade nobody.
I'll grade it.
No.
No, I can't.
The arc
I native can grade it.
Not grading nobody.
is the slide rule.
Oh no!
I want to know. I think
Not,
I really know.
not grading nobody's paper.
So what?
I have there's too many missing students.
To the moon. You can see it.
I want to know so bad. I'm itching.
No, you do.
Huh?
You should know you do fine.
No, I know I'm fun. I want to know what. I want to know if I did perfect. I'm a perfectionist. You know
I
that.
have in front of me the
I don't think I did. I think I got. Talking to the population.
scale. This better
It's called slide rule.
Oh, I hate these things.
You don't even know what is it.
No, I don't know.
I did this.
Wait, is it slide rules or slide ruler? Like the slide.
Slide ruler. You can call it slide ruler.
I know what it is. I just know that I would never want to use one.
I got 0. Yeah, I got 0.
It's one of those coolest things.
No, I think it's cool. Just no one invite you to that. Yeah.
Wait, did not.
An MIT student doesn't know what is it.
What doesn't matter anyway.
Alright, can we? was trying to do it after school, but I never remember.
All right, Andy. How are you? All right, Andy, Winston. I'm gonna teach you guys everything about conics today. Conics. You ready?
I learned angle myself. That was easy as hell. This one is actually really cool. Bro, at this point, just square it with cancel. Then I put 5 to the U. That'd be 5 to the U over 5.
Okay, I got 1 day to teach you. 1 hour to teach you everything about conics. It's not on the pre-cal curriculum, so you're not gonna learn it this year, but it's gonna be.
Will it be used in calculus?
Actually, no. Which is kind of sad.
That is.
So it's like nowhere? No, yeah. Is it like the matrix?
No, conics. Okay, you guys ready?
What do I need to be ready?
Grab a paper and pencil. Stuff like that. Do you know how to find equation of a circle? Do you know what's the equation of a circle? Okay, good. Teaching you right now. So x squared plus 4x plus y squared plus 10 minus 10y is equal to.
Paying attention.
Okay, can you find out how do you find the center of the circle, radius of the circle? Do you remember? Both. You don't know?
What?
How to find the center of the circle?
You're not a complete square.
Complete the square. Complete the square.
I don't know what you're talking about.
That's okay. I'm gonna teach you.
No.
Are you Kent or Oliver?
Cash.
He can pick up before you guys do though.
But I'm not hating. I'm just saying attention.
You're just laughing at the kid.
Yeah.
What? 10? Oh.
Very different. What did this equation mean though?
Great question. What does the question mean? Okay, so there are 4 type of conic in the world. It's basically built by double cones. Double cone looks like this. Okay, so if you cut it right here, you're gonna get a point. Does that make sense? To where both cones connected, right?
Yeah.
If you cut a flat line here, that's gonna be a what? Circle. Good. If I cut it this way, what kind of line? What kind of top part was gonna look like? What the top part of that cone? What's it gonna look like?
Parabola.
Not parabola.
I guys call it English. It's like a circle, but it's like curved.
Ellipse.
Okay.
And if you cut it this way, if you're looking from the side, it's called hyperbola. Hyperbola. If you just do this cut, that's called parabola.
Is it recording?
No.
But there's like no point. Did you What's the difference between
Huh?
a hyperbola and a parabola?
Did I end the stream? No.
Can you like make it change this for this one? Oh wait.
Wait.
Wait, just like keep the tree on.
Okay.
But people like they're gonna like go in the class and go learn this like all these things. You're gonna hear them talking about it's not a pre-cal.
Okay, so circles, the circles right here. So they depend on how they cut the double cone. Okay? So now, why do I know this circle? I know the circle is because x squared and y squared and it has same exact coefficient in the front. If they have same exact coefficient, which is 1, therefore it has to be a circle. So if you do this x squared plus 4x, I just have to catch Andy up a little bit, so it's okay. 10y, but I think he's gonna catch up to you guys. So I'm gonna leave this part blank. I'm gonna take this number 4 divided by 2 square. It's called completed square. And that's 4. So you're adding 4 here. You must adding 4 to the other side. Negative 10 divided by 2 square. That's equal to 5 square. That's equal to 25. So you're adding 25 on this side. You must add 25 to the other side.
Just divide by 2 squares.
Yeah.
And then you add that to both sides.
Yes, because to keep it balanced.
Okay.
So it'll be x plus 2 squared. Now you can factor this part. Plus y minus 10 or y minus 5 squared. That's equal to 36. That's equal to 36. So that means my center of the circle is negative 2, 5. And my radius of the circle is equal to, this is r squared. So r is equal to 6. Guys, why are you taking my test?
Just like trying to say our answers.
You cannot write anything on that. And you're gonna organize my pile into periods. Okay. Shh. Are we okay here? So this is not too hard, right?
I suppose it's just I hope I normally spend longer learning this, so I don't know if I'll be able to remember it.
You will be. You are quick.
Okay.
All right, let's talk about ellipse. We finished circle. Let's talk about ellipse. Vincent, sit down and learn. Ellipse. Bro.
This isn't Calc 3 though, right?
Huh?
This is Calc 3.
This might be in Calc 3. Yeah, it might be in Calc 3.
This is so like engineering. I won't
Huh?
Hurricane? Daniel do this.
Okay. Shh.
I won't even go like that.
All right, so basically a standard form of a circle is x squared plus y squared equal to r squared. That's if the center is at 0, 0. And if the center at h and k, that's going to be like this. That's center at h and k. Is that okay?
Okay.
Now I'm going to show you what an ellipse look like. The ellipse is actually interesting. It just say x squared over a squared equal plus y squared over b squared is equal to 1. So if they're equal to 1, and if you have a squared and b squared on the bottom, that's going to form an ellipse. So for example, if I have x squared over 9 plus y squared over 25, that's equal to 1. That's an ellipse. And not only their ellipse, it's very easy to draw because you know center is at 0, 0. And y is going to go 5 units to the top. And then 3 units this way. So this is your ellipse. Pretty easy, right?
Oh, that's what
Yeah.
you meant.
I just have to. Yeah, it's pretty easy.
Okay. So now ellipse has a focus. Vincent, are you learning?
I'm right here. I'm
Okay.
watching.
Okay, ellipse has a focus. A focus is the way, I'll show you a video how focus works. So basically, if you want to draw ellipse, the best way is to have a 2 stationary point, and you have it enough, like a rope is covered both sides. So draw ellipse by Mark Ruber. I don't know if he did one or not. I think he did one. So that 2 point is called focus. And actually, this is how Earth is rotating around something. Sun.
The sun.
The sun. So actually the sun is in one of the focus, not both focus. Sun is in the focus, and then they are rotating around the sun. There is a term called don't quote me on it. It's called perigee and apogee. It's the distance away from a certain thing. So those are actually pretty useful. Not only that, there's a way for you to actually, a long time ago, so let's say if you have kidney stone, let's just say you have kidney stone, like in the stomach, like in the kidney, and there's a stone that you want to break apart, right? But you cannot eat medicine because medicine doesn't like, you cannot eat like acid to dissolve a stone. That doesn't work because you're gonna hurt your body before you do things. So you gotta find a way to break that stone, and the best way to break a stone is actually use a sound wave. And what happened is a sound wave here that is gonna have a this is a focus right here, and there's two focus right here, right?
I don't see it up on the screen. Are you drawing? Oh, never mind. Yeah, I see it.
Okay, so this is a focus right here. Focus is always on the longer side of the ellipse. And what happened is, if you place the person right here, that's like this person laying right here with the kidney stone right here, right?
Okay.
And then so you're gonna have another source for another thing, and you're gonna produce ultrasonic sounds, like very, very high pitched sounds. And so the one wave is gonna hit here, and it's gonna hit bounce right here, and it's gonna be bounce right here. It's bounce right here. So that means it's like taking all the sound and broadcast into one small tube because it's magnified by the chamber. The chamber, whatever you hit from one side, is gonna hit directly the same place. So using that principle called elliptical principle, to break that stone, because you magnify the sound wave to thousands fold. Because every sound wave is radiated this way, right? Radiates everywhere, right? But you just magnify it by itself. And then so it actually break the stone up to pieces, and then you can actually pee it out. That's a very clever idea. And that's how they use elliptical principle. Does that make sense?
Yes.
Okay. So once you break it, then you say, okay, well, so how do I find the focus? The focus is pretty easy. It's actually, if this is a plus, it's the longer size square minus the shorter size square is equal to c squared. It's actually, so you're gonna form a right triangle. Ideally, it's to form a right triangle, but you're subtracting each other. So anyway, so in this case, it's gonna be the long side is gonna be 5 squared minus the short side, so it's gonna be the 3 squared, and that's equal to c squared. So that's 25 minus 9 equal to c squared. C squared is equal to 16. C is equal to 4. So that means it's 4 units up. So your focus is right here. 4 units up. 4 units away from the center on the longer side of the ellipse. You follow me so far?
So like it's the same distance top bottom.
Yeah, it's same distance top and bottom. So it's gonna be right here and right here. Sorry, that's not a very good drawing, but that's how this works. Ellipse, it has 2 focus. If it's one thing, it's called foci. If it's singular, it's called foci. If it's plural, it's focus. It's one way or the other way. I don't know which way is it. I think focus is 2. Foci is 1. I'm not good with English, so.
Focus is one, foci is multiple. Foci is multiple focuses.
Oh, foci is plural?
That's how it works.
Oh, okay. Yeah, like I said, I'm not good with English, but you know what I meant. Okay, so if you ever have a ellipse like that, so let's draw a sideways one. Can you tell me equation of this ellipse that What will be the equation of this ellipse? Caroline, somebody supposed to help you or no? So it will be
Is that
equations.
just x squared over 25 plus y squared over 9 equals 1?
Yep, it just inverted, right?
Yeah.
3 squared, so this is 9 is equal to 1. Yes, good. Okay, so here's the thing. Now, sometimes you don't have a perfect situations. You do have something that says, you do have something called, they're off center, right? And sometimes you can figure out what is it. Now, to complete the square for this situation, it'd be 9x squared plus 4y squared minus 18x plus 16y minus 11 equal to 0. So now the reason why I know this is ellipse because this 9 and 4 are different coefficients. And if you have x squared and y squared, they're probably like some type of things like this or like this. But its minus is going to go away. Minus is going to form hyperbola. Is a plus, it's going to join. So either circle or ellipse. Okay, so at this particular case that you can actually say, okay, well, 9x squared minus 18x, right, plus 4y squared plus 16y is equal to 11, like this.
Yeah.
You can also factor out a 9 because leading coefficient is 9, so you factor out, so it'll be x squared minus 2x. And this is plus 4, and this y squared plus 4y is equal to 11. Are you following me?
I think so.
Okay, the same thing, you divide it by 2 and square. So that's 1, so it's plus 1. And same thing, this 4 divided by 2 square. So that is equal to 2 squared, that's equal to 4. So it's plus 4 here. So here, you're not only plus 1 to the other side, you actually plus 9 and plus 16. Why is plus 9 plus 16?
Because you have to times by the coefficients, the
Yep.
rounded brackets.
And it's 9 minus 1 square plus 4 times y plus 2 square is equal to 36. And then you can divide by everything by 36. And then you become a something that you can draw. That's equal to 4 plus y plus 2 square over 9. That's equal to 1. You guys follow me?
Yeah, it's just a lot.
And the center is like 1, -2, and go in x direction is 2 units away, and 9 units away. So in this case, I will go ahead and draw it. I can say, oh, okay, well, that means going right 1, going down 2. This is my center, right?
Yeah.
And I'm going to go 2 units to the right, so it's going to be this part, and then 3 units to the top like this, and it's going to form like this. Now, on the foci side, it's going to be 3 squared minus 2 squared equal to c squared. So c is equal to square root of 5. And it's going to be the foci location is going to be the center, which is 1, comma, -2, but it's adding to the y direction, so it'd be plus minus square root of 5. Why is it plus minus? So it's going to go up 5 and down, up and down. So that's going to be, yeah. So that's how you find the foci. What'd you say? What is, okay, imagine that if you have perfect situation, like you have circle, right? If you have circle, then it's equal to 36. You to be divided by 36 on both sides, guess what? They just go in 6 unit to the right side, 6 unit to the top. That's a perfect situation. There's something called eccentricity, which is you learn in Calc 3, and they will actually tell you the relationship, the proportion of the focus and the things. So right now, this is a circle is a perfect ellipse. You can still set circle equal to 1 if you wanted to. Right, just divide by both sides by 36. You got Move the x direction 6 units, move y direction 6 units. Is that okay? And there we go. There was ellipse. So ellipse is actually used for a lot of situation. In theater, they actually use that as well. In Congress, they actually have that. So one of the president from a long time ago, I forgot which president is. He was very clever because that's why they call it Oval Office, right? Because it's in the Oval, but in Congress it's like this. So what happened is like, he find out that like if this president is like Donald Trump, right? And he want to hear what Democrat was saying. You can hear from one side. So he was strategically placed right here, and he will listen in what other people were saying. So he was very clever because he was actually understand a lot about math, and he actually deal with that, so he can actually hear what other people's conversation is. If you go to Oval Office tour, they actually show you that. They actually show you that there's actual things happened in the past like this. That's a very annoying knock. Okay, does that make sense? Okay, so therefore there's an ellipse. Ellipse is using for elliptical principle using theater. A lot of Broadway shows want to broadcast their sounds, make their sounds more like things. They use the idea of this. Who was that?
It was Mariana, and then the other blonde girl that's Navy.
Oh, Claire.
They're doing like 10 stuff.
Oh, okay. Yeah, does that make sense? Okay, so I'll give you one and ask you to find everything about this things. So, and I'll give you some. Oh, by the way, this is called a major axis, just a vocab. From here to here, this is called a major axis. And this here is called minor axis, which is kind of makes sense. And that's it. No crazy stuff. So let's you try to find one. So 9x squared plus 25y squared minus 36x plus 50y minus 164 is equal to 0. Now you can tell me about the center, the focus, this point is called vertices. This point is called vertices. And this one is called covertice, which is kind of makes sense. Covertice is on the shorter side, the longer side is vertice, and that's pretty much it. Actually, if you guys ever seen an elliptical pool table, they are like two. You can shoot it from any side, it will always go into the same hole. It doesn't matter how you hit. And that's how elliptical work. Can you tell me the graph, center, the foci, the location of foci? By the way, your satellite, let's say satellite, and this is the Earth. This is Earth, and it's in the focus. And in the future, for reference, this is called an apogee. APOGEE, and this part is called perigee. So if you, in case you want to become astronomer or astrophysicist or work for Elon Musk someday, I don't know.
Wait, how's the
No. Why the fuck are we talking about kidney stone? It's like, so you have kidney stone. I was like, what?
Yeah, it is. It brought back
You like-
my life. My father hated that. That's one place I never wanted to see. Yeah.
So it's all.
What's wrong? What do you mean it's wrong?
What's wrong with the apple?
I didn't want to see him. Alright, Yeah, even the captain now.
Wait, no.
Like a little.
Wait, there, no, I you know, with Papa.
Like, you know how many checks that I
Yeah, I saw one coming from outside. Whoa, whoa.
like this.
That's completely. I don't. You know, it's what happens to me.
Well,
It was like this or
like
yeah,
so the way I don't know.
Wait, so you don't do bonus?
I was thinking I was better find a slug over okay. And then there's one
I didn't say bonus.
yeah, so you're only doing I can really do this
On my past test, like I got every major thing right. Like maybe like actually like I integrated wrong. I did like incorrect integration. I got like two things. And then everything
If you are not under the supervision of a coach or a teacher, please exit the school campus now.
Oh, bro, can you stop?
Okay, so you guys finish?
now,
Okay,
no,
start.
they're not calculating.
Do you understand my handwriting? That's probably the key. It's 9x squared plus 25y squared minus 36x plus 50y minus 164 equals 0.
I'm just taking.
Just go back up to the work.
Yeah.
No, that. What am I doing wrong?
Focus, center. That's it. Well, focus and those the center. Not the focus and then the focus.
So you're gonna be like
Let me see. The middle is the focus, right?
The focus is located on major axes. So you have to figure out which one's major axes. So they are gonna locate on the major axis. But you have to complete the square correctly.
Focuses are these.
Yeah.
Middle is the what? Center.
yeah, I think they should
Minus.
Is the focus square of 300?
What's your center? Your center should be a nice number. Mhm.
Not. What did I do wrong?
I will tell you what the number is supposed to be. Hold on a second.
I got
Thank
like
you.
x minus 2 squared over 25 plus y plus 1 squared over 9 equals 1.
So bottom is a nice number.
Yeah, bottom is 25 and 9.
Oh yeah, and that should be fine. And your focus should be square root 11 plus minus away from the center.
164 plus 136. That's 225. 425.
What is it doing? So the whole thing is the center, or like
Wait a second. Can I just?
equation,
What?
in the equation, which number is the center after you solve the whole?
The center is on the top.
Squared plus y.
So that's what, like.
Okay. Maybe.
So negative.
You know, we're on time. We're gonna finish. Mm,
Okay.
I saw. I know what you mean by a squared. No.
No, it's Thursday.
What do you mean by a squared? Like, what do you do? What is a squared and b squared? Like, what are they in the whole equal square?
It doesn't matter, Avis. We're just knowing that this is the distance away from the center 3 units, and this is 5 units.
Oh. Basically part of it.
So don't worry about it. For the focus, just take a look.
Yeah.
Because the adding is the fact.
I mean, yeah, that.
Wait, no.
Not all of them.
What?
225.
And about 225.
Yeah, so 9 divided by 9, 25, right?
I'll read all four. I only need to repeat myself. I told you before. You never build enough muscle memory for you to know what you're supposed to be doing. So if you don't do that, there's nothing I can do. And you're not coming back to tell me, says, I can do that. Because you don't do the work you're supposed to be doing.
I wish to have is what actually of a textbook. Could you give me 3 chapters of the textbook that I should go?
5.1 to 5.4. Well, actually, 5.1 to 5.5.
It's so 5 over 8 and 3.
Your textbook.
Wait, no,
No, it doesn't.
5, right?
25, I think.
Yeah, 5, okay, so.
How do you get 25?
This is 15, this is 5. This is 164, adding 36.
Did I just add incorrectly or something?
Yeah, so this is 225. So we can divide by 225.
Why are you squaring?
That's what I tried to do. Am I just dividing by 225 wrong then? Is that-
Oh, you said,
Divide 225.
so the focus is 25
Divide
squared
this?
minus
Okay,
9
I just can't
squared.
do basic division.
Okay.
Are you sure it's 25 and 9?
Yes, bro, I did the same work, we got the same thing, 25.
I'm not sure if mine is right. That's the problem.
Find the area. Yeah, like find the area that you're trying to achieve.
Square root of 5 and 44. Am I not wrong?
I just miswrote it when, oh, that's so dumb to mess up. That's what happened.
Long squared minus short squared equals focus.
Okay, so it's fine.
Okay, then it makes sense.
So 5 squared minus.
But the x is not
It's
that.
gonna be the same
X
thing.
is here. X should be. Equals 5. X should be 7.
Is guys your work again?
Ooh, I got it, bro. I got it.
I got it. Let me see his work. I think I'll get it. Yes. I mean, lot.
Look, bro, it wants the
So-
x and the y.
Yeah.
When you get this, you don't have x and y. You have the
Yeah, no, that you have to like go
x
square root.
equals
So
to x equals to 7, then y equals to.
And then
what's
from
that?
here,
Y said no.
it's,
You mean 3 and 5? 3 and 5. And he subtracted. What he did?
You don't want it to be 0.
No, he went.
It wants to
He went
equal
y
to
minus. He went y minus x equals c. So it would be what, like 9 minus 25 equals.
No, the longer side is subtract 4. So just take it whatever longer it takes.
So 25 minus 9 equals c squared, so that's just 4.
So that's a 4 unit, depending on which one's major actually.
Yeah, so that's 4.
Long
is
side.
So the center is x2 minus 1. And the focus are 2, 1 plus minus 4. So look, this is focus right here.
No.
Longer,
No.
minus 4 equals this is squared. So it's this is squared. This is the square of this actual distance. So it's not 9 squared, it's 3 squared. So for here, so it's 9 minus 4 equals, so it means that's square root of 5. So it's gonna be 5 squared minus 3 equals why not? 16.
Okay, I gotta go pick up my son. You guys gonna have to figure out how to do hyperbola. Hyperbola, the only difference is the x squared and y squared minus sign. And that's the only thing. Instead of drawing an ellipse, you draw in a box. And that box is gonna draw 2 diagonal lines, and it's gonna graph like a hyperbola. So this is happening in sonic wave. Like when you hear like a jet flying through the air, you hear this loud noise. This is how the sound is radiated. Once you break the sound barrier, and they go split this way. So that's called hyperbola. It's also used for another application can be used for is like in a nuclear reactor. And they use to diffuse heat. Oh, that's why their structures look like a lot of structure look like. So you and him can figure out now. If you have time, you teach him the inverse sine trick. Like arc sine of 1/2. But I have to pick up my kids up again. This is severe.
Oh, when am I think what? I do have to leave pretty soon.
Okay, then we can talk about it more tomorrow.
My dad picked me up, but it'll take a bit before you arrive, so I might have 10 minutes actually.
Can you teach him arc sine and arc?
It's short.
Don't go over this. Can you teach him arc sine? Arc sine, sine inverse, and then you show him how to draw a right triangle and the T inverse. I'll be right back.
Oh, where are we gonna be? Am I gonna be here tomorrow? Yeah. Don't forget about the machine. I'll pick up the what? He's definitely gonna get mad at me.
Alright, that's not a good jacket, bro. The only jacket is always one.
It's a great jacket.
It's not good enough.
Give me the fucking jacket. Give me the fucking jacket.
I'm gonna use this one, bro. I'm gonna use this.
What are we doing?
I'm gonna see what you know. You think some alcohol?
I need paper.
You're gonna do it for what? You can't have. I didn't try to know what you want. Yeah, I'll have that number. It would be.
Listen, man, I'm like almost out of cannot be getting any
You can't be getting diddy.
Yo, okay, yeah, but you don't tell him.
Plug in 1 over each square. Oh, what are you saying? I should keep it quiet, bro? Hell yeah. Take it and keep it quiet?
Yeah.
Hell no. That's gonna
Right now, you're not being quiet.
That's how diddlers are made, bro. They can say quiet. It's like.
Why is it E squared?
I don't know.
It's lower than.
But it's not square though.
No, not fortress.
Yeah.
Oh. Okay.
Sever, you dumbass.
1 plus L minus.
I was like, oh, should I tell him this other way? No way you have to do this stupid. Look at you. You're not fucking moving.
One, who did it though? I'm gonna drop myself. Look at this. But actually, I can't draw shit, bro. I was the artist. I would literally destroy the kids in kindergarten. You know, in the 6th grade.
Yeah. Okay, sure.
Alright.
I got here.
Do you know how to do the triangles? Yes, like for example, like can you solve this point?
Because if you think about it, you can guess
Let me
fine.
find the
Because like, I was really thinking about this too during the test, but I was like, I'm just not do
3,
it.
5.
I was thinking like, okay, if one is
Can I
zero,
like write it out?
less than one,
Let me
negative.
five. 4 is
So maybe it's
that.
negative.
So
So
that's
that's
just
too like
one.
that's too like chance based.
Yeah.
So I use it.
Okay.
And then I have to.
You can find a good
Anything
question.
that's possible.
Okay. That's so weird.
And then they're saying it's well, but like the numbers you need to plug in, it's like
You know how
you can't plug in. I mean, I'm sure these people just
But
it's almost exactly. So plug in
I
that
have
number.
written. They honestly taught me.
I don't know.
There's no aspect.
Like that's wait, what? I don't know.
That's so weird.
Like, could you find this sign up?
Yeah, I have one too. Yeah, this one doesn't have a number. Or names.
How do you find this? I don't know. You know.
I know.
Yeah, I
I
don't see how to find this. How do you find this?
haven't seen this problem.
Here.
Okay.
Okay.
Bro, how do you know what your name?
What is sign equal?
No name?
That's optional.
Like,
No, not judging me. We're just seeing people that did good. And we're like,
oh, don't look at my right?
So you basically
Bruh,
want to
it's a minimum. Yo,
So
I'm gonna ask my good job. It's my good job.
I.
Reading about some shit. So something like
Just remember, like, I'm like dumb as hell, so.
yeah.
Don't say that you're talking about.
Well, because yours on self, and I'm like,
Okay.
So you basically.
I highly doubt this, but.
Yeah, Corbin's a different type.
I'm gonna find. Listen, I'm really going to not do this event for my.
The hypotenuse.
I'm not gonna say what is actually no. Fuck that.
Okay.
Y'all were in this game so little.
Okay, wait, so.
Yo, that's.
Oh, then are we?
Okay. And how do you find the now? I'm asking for the cosine.
So the X value, that's just Pythagoras theorem. Right?
Exactly. How do you find it?
Yo, Kaden also did.
So yeah, weird.
Kaden also did.
Close.
I'm telling you, all these people guess, bro. I'm telling you, they all guess.
What?
For 8
What's
feet.
third? No, okay, I don't.
With the
It is.
max and max on it.
Oh, people are gonna be that's what I was
What
thinking.
doesn't make sense is that how could it be negative? How could I literally plug in a number in between that and get positive, but the answer's negative?
Yes.
1
Maybe that makes
5 X equals.
If Anthony says it's positive, how could it be negative?
So
I think Mr. Gates wrong, bro. I think Anthony's smarter than that.
Okay.
So now, if you want to find cosine, what do you do?
Is that? Oops.
Don't tell him next.
What do you mean?
He's not no games. We don't have to do that's so.
Not just 5.
Yeah, I love it. He's my favorite.
Oh, no, hold on.
Alright, I'm the guy.
Wait, I'm talking about like VZ's Anthony or?
Okay, so.
I don't know. I just.
So,
Okay.
the Jason
Okay.
correct.
The
So that would be 5.
I don't want to be caught. Maybe. Good job.
There are two.
No!
Somebody barely.
Neo put minimum. I'm telling you they guess, bro. I'm telling you they guess. I should have stuck with my instinct, bro. I was thinking like L and 0, so it was like that it has to be negative. Yeah. Oh, yeah, that was something. I was like, okay. But since it's 1 plus, I'm gonna assume prove that.
This is how you find the mistake.
Okay,
Maybe
I haven't done this in a very long time. I'm like trying to remember. Okay, so to find like the maximum, you said y prime equals 0, right? You said y prime 0 and then find what x is.
Yeah.
Yeah.
That's all right if you put that on the line.
Then how?
There is
Okay, wait. Okay, now you
R. The number. Plus 1.
Sure, it is.
Yeah, 0.
Okay, so yeah, this would be negative.
cosine. And
Okay.
then
So
R.
think about this. So if
Yeah.
this is all even x, we have to
These are
Okay,
basically
I can't use
sine.
mine. Okay.
Okay. R
sine means sine inverse. Arc cosine means.
So if you have,
Fuck you.
okay.
Tangent
So if you
inverse.
have, why do
You
you
know
know
what inverse
is
is?
equal to?
It's just sine and
Yeah, that's what inverse is for the equation.
Where
Where here it's the
e to the
where
negative
here
one
it's basically saying.
is the 0.
So sometimes you
So
have
if you
like
plug in right
this
here,
is sine of
e to the
this
negative 2,
number.
then you have
Usually
ln
two.
e to the negative 2, ln e cancels out plus 1, so now you have negative 2.
Yeah, when it's
plus
sine
1, then
equals
you can
1.
negative 1, which would make it sine x.
sine equals
And then if you have just plug in e to 0 here,
angle
then you have
Yeah, well, like what is it?
ln e
like
to 0, ln b
pi
cancels out
squared.
sine
Yeah,
and cos of
Okay.
negative.
right, so
Sine of x equals to 1 half.
You know,
then
Okay.
pi then could it be like pi over 6 or pi over 6?
Exactly. These two.
it wasn't because of the 1 over e.
I think I plugged in 1 over e squared into the thing, but I should have plugged in e to the negative 2.
Yeah.
Not 1 over
Okay.
e squared.
Yeah, you just have to put it in your mind. So
Wait.
you do.
Hold on. There is a important. Ooh, I missed the negative. It says there is an important rule. I'm doing 1 plus 2 is that you only have this part of the circle. We're not allowed to use this 1 over e squared. We have sine inverse 1 minus sine 2 ln
These one, this one.
Obviously that goes here. Sine 1 plus
Minus 2x?
inverse. So your x equals to 1 half. Good. That means I was thinking it was 1 plus 2. X equals to pi over 6.
But it was because you did 1 over even the squares.
Like basically the sine inverse this part. Yeah, I was just thinking.
But how, so is it literally just this part between this and all that inverse?
Yeah, that's what inverse means.
Okay, that's
Like this part doesn't exist. If they had they gone that deep, you look at it, she gave us a look at that this part doesn't exist. Okay, for example, when you want to say, so like, would you know what the sine inverse of negative?
That makes me like,
Okay,
I was
that
putting
would
numbers.
just
Just plug it in.
Yeah.
Negative 2. Yo, I see that.
pi,
It makes some.
no, 11 pi. Negative nothing.
Okay, let's just. I can't get seriously. I have pizza. I drink Dutch.
That's okay.
I have fractures.
You know what?
No,
Okay.
I just ran it out.
You're going like basically you have to yeah.
So then do I have to say?
I was plugging like 0.1.
That's why to everything, like, don't only do fractions like variance. I try to keep everything like x to the negative 1
Negative
instead of
5
1 over x.
That's all.
Okay,
Not mentioned it.
that's what, yeah.
And then, I didn't even think about this during the test. This was after. Oh, by the way, during the test, it's same for tangent. I didn't have shit. Tangent is literally the same rules. This circle is only allowed like.
I promise guys, I am smart. They just take me like 5 minutes to lock in.
You might not see them on the outside.
Hey, fuck you.
Inverse.
Did you go to my test grades?
I haven't seen
Well,
I got a 5 on AV.
Okay.
For the
If
practice.
I never see your test grades, then I'll never think like.
I'll show you like my one like a couple of these for test grades. Yeah, for like all of like the Calc AV mock exams,
it's at negative pi over
only 1 4.
Negative power is good because they can't go all the way. It just wants to go this. It's all important. All right. For cosine.
See, Mexicans don't learn shit, but at the end they lock in.
Yeah.
All that matters.
For cosine.
Yeah.
Saying a lot. Oh, fuck.
This is positive. Oh no.
I'm looking right now. It's in.
Oh,
Oh, he is a friend. Oh, yeah, the live's on right now.
Corbin reaching. On the rule. Is this all? Because if you have two parts on the same side.
Yeah, this school here. Wait. I think they guess. So if I is like right now, so like you know what? Wait, I still think they guess.